There's no question that the black holes at the centers of galaxies have a profound influence on their surrounding. They send out these huge jets moving at almost the speed of light. And those jets can send shock waves into the surrounding medium and change their surroundings completely. They have a dramatic influence.
Not only can they blast away huge quantities of gas, but they may even sterilize the galaxy so new stars can't form.
The supermassive black holes at the center may be responsible for limiting the size of galaxies. In principle, galaxies can grow to very, very large sizes, and what we see in the universe is that they don't. And we think that the supermassive black holes at the center may be the culprit. They may be responsible for preventing runaway growth of galaxies.
We usually think of black holes as God's dumpster, but they really are actors on the galactic stage.
If supermassive black holes can wreak so much havoc, what's to stop our own monster of the Milky Way from wiping us all out? It all depends on the monster's diet.
Most of the time, a black hole isn't eating. It fasts more than it feasts. But when a black hole feasts, it can have a tremendous effect on the surrounding galaxy.
The more black holes chow down, the more matter and energy will blast outwards.
One of the key differences between galaxies with supermassive black holes is whether or not their black holes are lit up, because they're basically binging on a lot of material in its surroundings.
For years, our black holes seemed to be fasting, and the Milky Way was peaceful. But in 1999, the Chandra Space Telescope detected a powerful signal from the galactic center.
Station 34, Chandra OC.
An explosion near the event horizon. Is this the beginning of a black hole binge? For trackers of the galactic center, the blast is a wake-up call.
It was a hot piece of news. A remarkable fact for all of us was, for many years, how inactive the black hole was. And all of a sudden we saw, well, there's an object there which wasn't there before.
Reinhard Genzel has been watching the galactic center for nearly 2 decades. Like Andrea Ghez, he's been tracking the orbits of stars, helping to prove the existence of a black hole at the heart of the Milky Way. Now both Genzel and Ghez will shift their focus and try to measure the black hole's appetite.
One of the big mysteries about the black hole at the center of the galaxy is when we see emission matter falling onto the black hole, or rather the black hole eating up its surroundings.
Genzel and Ghez are joining a worldwide effort. Chandra in orbit will take X-ray pictures of the galactic center. At the same time, 5 major observatories on the ground will probe the black hole, all trying to count calories. Genzel heads south to Chile, while Ghez and Becklin climb a mountaintop in Hawaii. Telescope time is precious. There's no room for mistakes.
When you're there, it's an incredible rush. I mean, you're very much on for the few nights that you're there, hoping the weather cooperates, hoping that the instrument cooperates.
How's the Yak 4 look on the oscilloscope? Does the timing look okay?
Better now.
Okay, let's see if there's something there. Madeline, we're ready to go?
The teams have 5 short nights to find out how much the black hole is eating by measuring the energy that flares out.
Zoom in a little bit more. All right, so first night. Doesn't look like we've got any flares.
Chandra headquarters in Cambridge, Massachusetts. The first night turns up only noise.
4 more chances, guys.
Night 2. Chile has problems.
No.
We have to redo the acquisition of it.
Even if there are flares, the Chilean telescope can't see them.
The correction was
unstable.
Yeah, unstable.
A patch of humidity is confusing the computers. The crucial adaptive optics aren't working, and everything's a blur.
Extremely.
Okay, now we have a problem with the 8-meter, with the main mirror. The 8-meter mirror seems to be deformed.
In Hawaii, it's not much better for Gez and her team. The Galactic Center is playing hide-and-seek behind overcast skies.
We're fighting with clouds. It looked better just a moment ago, so it looked like we were just ready to go, but now it's looking like yuck.
The Hawaiian forecast predicts even more clouds tomorrow. The team is getting anxious. Finally, on night 3, the German team's luck changes.
Very in correction.
Look at this. Right. It's really flaring. To calibrate. Yeah.
In Chile, they spot an outburst.
That's the best flare event that we saw during this run. Definitely.
A new point of light appears in the starfield, one that wasn't there before.
This is a good sign. Very nice, very nice.
Here we can clearly see a region between those two sources where there is no other object. And here we have the same region, the same two sources, and now in between we see an additional source. So this is a flaring state of Sagittarius A star.
JPL-COM, Chandra C.
When the Chandra team downloads their data from space, they see it too.
Oh, yeah.
The X-rays show a spike that coincides with the Germans' flash of light. Genzel checks in with the Hawaiian team, but they're in the wrong time zone.
News from our colleagues, of course, telling us that they are a few hours further west, so the sun hasn't even set yet.
The Galactic Center hasn't risen above the Hawaiian horizon, and Gez has missed the flare.
This part kills me. Waiting.
But the next night, Gez finally gets what he's looking for.
Well, that image a whole lot better. Really?
Yeah. Really?
So in fact, we can see flaring activity where we think we're seeing matter fall into the black hole. And just a few minutes later, it was absolutely gone.
This now you see it, now you don't flash of light is an explosion of energy produced when matter rushes toward the black hole and some escapes.
We were taking measurements and you didn't see anything from the black hole. All you saw was a star, and then bam, it was there and bright, and 15 minutes later it was gone. So that was our moment to make the measurement, and it was extremely exciting to know that we'd actually been able to catch it.
The teams are thrilled to capture a handful of flares at the heart of the Milky Way, but they're just snacks. Nothing compared to the giant jets seen in distant galaxies. What's more, they're looking like rare events. There's simply not enough matter near our black hole to provide a large continuing feast. It seems, at least for now, the giant's plate is empty.
Our black hole had a wild teenage life. I'm pretty sure of that. It always had jets. It threw a lot of matter out. It had a grand old time. And now it's decayed into the old folks' home.
But what would it take for the monster of the Milky Way to come out of retirement? Could explosive jets of energy blast across our galaxy in the future? Tantalizing clues are turning up in the coldest place on Earth. A Smithsonian team is tuning into high-frequency radio signals from the Galactic Center. The best reception is at the South Pole. Not as nice as Hawaii, but the date is worth it.
There's some of the gas falling in toward the black hole in the galactic center.
Reading the radio signal, Anthony Stark detects just small amounts of gas feeding the black hole. Nothing too serious, but farther out, about 400 light-years from the galactic center, he can see signs of something much more alarming. A vast ring of matter is gradually growing bigger.
This storage ring then builds up until it coagulates into a single gigantic cloud of about 30 million solar masses.
When the ring reaches a tipping point, it will condense into a giant cloud, triggering a dramatic starburst event, a storm of stars forming and dying quickly. What's left of the gas cloud will spiral down into the grasp of the black hole,
which then rapidly spirals in and feeds the black hole in the galactic center, making the Milky Way an active galaxy.
When the feasting starts, the fireworks will be seen across the Milky Way. But don't bother marking your calendar. Dinner time isn't scheduled for at least 10 million years. The Milky Way will survive its black hole's upcoming feast, but it isn't likely to survive the threat further down the road: galactic cannibalism.
Our galaxy, the Milky Way, is not immune from these colliding galaxy scenarios. We've got neighbors.
2 million light years away, our closest neighbor, the Andromeda Galaxy, is charging toward us at almost 700,000 miles per hour.
We're falling towards each other, and one day we will collide.
Knowing the galaxy's dimensions and the laws of gravity,
what our simulations show is what could happen basically in quite a few billion years from now, when the two galaxies will actually approach each other and merge.
the merger will take more than 2 billion years, while the galaxies circle and entwine.
Imagine what that might look like from another galaxy. They'll see two grand, beautiful spiral galaxies moving towards each other, slowly losing their shape. They'll see new avenues where stars and gas can funnel down towards this newly formed center, feeding this reborn monster.
The collision will send a blizzard of stars and gas in all directions. Some will shoot toward the crowded core of the new galaxy, spurring massive explosions.
In the process of merging, there will be a very strong starburst event occurring at the time of the merger as all of the gas is being funneled towards the center.
Amid the turmoil, chances are our little solar system will either witness a spectacular show or be flung out of the galaxy into the voids of space. The Milky Way will be destroyed. But what about the black hole at its center? Most likely, it will merge with Andromeda's, a monster 50 times larger. Stars and galaxies may come and go, but supermassive black holes just get bigger. Once considered freaks of the cosmos, black holes are coming into their own, claiming their place center stage in a violent, changing universe.
As we forge ahead in trying to understand how we came into being and how all of the matter got put down in the universe, we can't leave black holes out of the picture because it seems they play a fundamental role on very, very large scales.
Black holes not only wreak havoc upon the landscape in which they're embedded, they actively shape the landscape. So black holes are kind of the spice of the universe.
Black holes are a major player in the evolution of the things that light up our night sky. They are, in a sense, the secret shadows behind the waltz of the galaxy.